In this video, we'll talk about several different rules for the definite integral. When we talk about an integral, it's the area under a curve over a closed interval, a to b. Now, in our train example over the last 2 days, the train was moving for a certain amount of time at a certain velocity. When we think about velocity, if you're moving forward, your velocity is positive. But if you're moving backwards, your velocity is negative. This first rule kind of stems from that. If we have the integral from a to b of f of x dx, we might get a positive value. But if we were to switch it and go from b to a, so go in the reverse order, that's going to be the negative of our integral from a to b. The next one is the zero rule, saying that if we have the integral from a to a of f of x dx, that's going to be 0. And that's because a minus a is 0, which means the width of each rectangle is 0. The constant multiple rule says that if we have some function multiplied by a constant and we want to find the integral of that, we can just take the constant out front and find the integral of the function and then multiply it by the constant. The next rule is an extension of that. If we have the negative of a function, we can bring that negative out front, find the integral of the function, and then negate it. That's because in this case, just like in the previous one, the constant is negative 1. So we're just bringing that negative 1 out front. The sum difference rule says that if we have some integral from a to b of f of x plus or minus g of x dx, that's the same as the integral of the first function plus the integral of the second function. Our additivity rule says that if we have some function that goes on the closed interval from a to b plus another function that goes from b to c, where the upper bound is the same as the lower bound of the next function, and they're both f of x, or they're both the same function, then that's the same as the function from a all the way to c. So our closed interval becomes a to c of f of x dx. Our min-max inequality rule says that if the max of f and the min of x are the maximum and minimum values of f on the closed interval a to b, then the minimum value of f times b minus a is less than or equal to the integral from a to b of f of x dx, which is also less than or equal to the maximum value of f times b minus a. Our domination rule says that if we have some function f of x, which is greater than or equal to another function g of x on the closed interval a to b, then the integral from a to b of our f of x is also greater than or equal to the integral from a to b of g of x. Likewise, if f of x is greater than or equal to 0 on the closed interval a to b, then the integral of f of x on the closed interval a to b is also greater than or equal to 0. So now let's look at a few of those rules in an example. So if we're given 3 different integrals right here, we can figure out different things based on our integral rules and based on the given. So our first one, we want to find the integral of f of x dx from 4 to 1. If we look at what we're given the integral of f of x dx from 1 to 4. The only thing that's different here is that the order of a and b are switched. Well, that goes right along with our first derivative rule. If we switch it, all we have to do is negate the value. So this one becomes the negative of the integral from 1 to 4 of f of x dx. Integral from from positive 1 to 4 of f of x dx is negative 2. So I'm going to do negative 2, which is just 2. For b, we want the integral from negative 1 to 4 of f of x dx. We have the integral from negative 1 to 1, and then from 1 to 4. So this will be our additivity rule. The upper bound of the first one is the same as the lower bound of the second. So we can make that jump and go straight from A to C. So here we have negative 1 to 1. The upper bound is the same as the lower bound here. So this is the same as the integral from 1 to 1 of f of x dx plus the integral of 1 to 4 of f of x dx. The integral from negative 1 to 1 f of x dx is 5. And the integral from 1 to 4 of f of x dx is negative 2. Therefore, we get 3. Part C puts together two different rules. We're adding function f with function h, but we also have a constant in front of each. So this puts together the constant multiple rule along with the sum and difference rule. So this will be the same as, following the constant rule, I'm going to pull this 2 out front. It's going to be the same as 2 times the integral from negative 1 to 1 of f of x dx. Here we're adding, so I'm going to continue to add here. Following my constant rule, I'm going to pull the 3 out front, integral from negative 1 to 1 of h of x dx. Now my sum and difference rule allowed me to split this into 2 separate integrals. So now I'm going to go up to the top. Negative 1 to 1 f of x dx is 5. So I'm going to have 2 times 5 for that piece, plus 3 from my constant, times the integral from negative 1 to 1 of h of x dx is 7. So this becomes 10 plus 21, which is 31. All right, next one. The integral from 0 to 1 of f of x dx. These are my two functions of f of x dx. Neither one goes from 0 to 1. So this one I do not have enough information. I cannot answer that one. Let's see. E goes from negative 2 to 2 of h of x dx. Here's my h of x function, but my bounds are different. So again, I have not enough information. And my last one. I want to add together f of x plus h of x. Well, following my sum and difference rule, I should be able to split this up. However, if I split it up, I have enough information to talk about the integral of f of x over the interval from 1 to 4, negative 1 to 4. However, I do not have enough information to talk about h of x dx over the interval from negative 1 to 4. So again, not enough information. My next example here is going to show the max-min inequality rule. So I want to show that the value of the integral from 0 to 1 of the square root of 1 plus cosine x dx is less than 3/2. So to do that, I'm going to find the maximum value of the square root of 1 plus cosine of x on the interval from 0 to 1. Well, I'm going to look at a graph first. And I pulled this up in Desmos. The graph of this looks something like this and continues on in each direction. So my maximum value between the interval of 0 and 1, so here's my interval right here, my maximum value occurs at x is equal to 0. So when I put 0 in for x, square root of 1 plus cosine of 0, the cosine of 0 is 1. So this becomes square root of 1 plus 1, which is the square root of 2. My maximum value occurs right here at 0, negative 2. So my maximum value over this interval is the square root of 2, which is approximately 1.4. Since 1.4 is less than 3/2, I have just showed that the value of this function must be less than 3/2. Because if the maximum value occurs on this, the maximum value is going to be greater than the integral itself. So here the value of our integral, so this value here, is definitely less than 3/2 because it is bounded by the square root of 2.